Good morning, everyone, and thank you very much for joining us for today's webinar, Carbon and Net Zero in Low-Rise Residential Sector. My name is Claire Hepburn. I'm the Deputy Registrar at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. So before we get into today's webinar, I just want to share a few housekeeping items with you. We will be recording the session for quality and educational purposes. To maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. We very much encourage your participation through the Q&A video. So at any point today, if you have questions for our speakers, please put your questions in the Q&A window. You'll just see that little icon at the bottom of your screen. And at the end of the presentation, the last half hour will be designated for that question and answer period. If you're seeking continuing education hours, just note that your attendance is crucial. You'll need to attend 80% to be accredited those hours. And just allow us a few weeks. We're actually experiencing a little slower than normal time to upload those hours. So just have a little patience with us there. We have a automatic closed captioning services for anybody who needs to use multiple languages. And finally, we also will note that our presenters today do not provide any insurance, legal, or practice advice. And the OAA does not bear responsibility for errors or omissions in the discussions during the webinar. And now, finally, I'm very excited to introduce you to our speakers today. We have Kim-Marie Degenkolb, Chloe Doesburg, Carolyn Moss, and Brad Tapson. Welcome.
Thank you, Claire, for the introduction. Hi, everyone. Thank you for joining us. So yes, Claire mentioned, title is Carbon and Net Zero in the Low-Rise Residential Sector. So that's what we're going to be focusing on today. I will be starting off with a little intro just to set you up for the topic. We have done this presentation in the past before, so you might have seen us before. We update it regularly just to reflect, the amount of change in that kind of topic. But for those of you who haven't seen it, I'll set you up a little bit, and then Brad, Chloe, and Carolyn will take you through some of the case studies and apply that knowledge. And you might be asking why the four of us kind of got together and how we met. So we all knew each other beforehand, and we were all kind of doing this research in our own little offices. And then we were like, why don't we share this? There were so many questions that everyone always had. And instead of everyone duplicating work, we decided to create something called Net Zero Architects Network. It is mostly a forum at this point where we get to ask questions. So for example, if you're looking for a professional contact, like an installer, or if you're looking for someone who has tried a methodology before, whether it worked or not, we have that forum. It's all regulated over Teams right now, but you can also reach out to us under this QR code. I believe Claire is going to send out the PDF of this to you later, so you can always scan it later. You're welcome to join us or just ask a question. So again, I'm Kim. I will start you off with a little introduction on the topic. I currently work at VETTA Windows. My background is building science. That's what I studied, and I did work at an architecture firm for a little bit, which got me into this topic. So we did a lot of carbon accounting at the firm, and I was leading that. So, and VETTA also does a lot of carbon accounting at this point. We do focus on the windows. We also did our EPD last year, which I was involved in, which I'll touch a little bit on later. But yeah, so I've been involved in that space for a while now. And just to give a little background on why specifically the OAA and us are meeting about this and why we think it's important that we look at our carbon emissions. These graphs are from 2005 and 2018. So we can see that the building emissions actually went up from 18 to 24%. You also see that the actual carbon emissions below. There's two reasons for that. One is we're actually emitting more and more, so our buildings are actually becoming more carbon intensive, unfortunately. The other reason is also that some of the other industries that are taking up a part of the pie are becoming smaller and are reducing their carbon footprint. So we can see electricity has gone down significantly this is Ontario, obviously not every province would look like that. You know, and that fluctuates. It might look different again. They haven't released a new graph, unfortunately, at this point. You can see transportation went down a little bit as well. So that just makes the building industry a larger chunk of the pie, right? So it is really important that we kind of catch up with those other industries in our carbon accounting and reduction. And the reason why a lot of people are hesitant to implement it so far were that we associate this with cost. But the good news is, as long as you implement it very early on in your design process, it doesn't actually have to be a big cost burden on your project. And that's why we're here today, to give you some, easy, simple things that you can do right off the start when you're starting your schematic design phase to avoid changes and headaches and extra costs later on associated with this. So just to set the kind of framework and terms that we're probably going to keep referencing, when we talk about carbon, it's made up of two different emissions. One is the material carbon emission, also called embodied carbon. That's what I usually reference it as, but you might hear other people say material carbon emissions. That's what happened with the materials that you use. So in the factories, anything that happens before the building is installed, really, or built. So from your windows to your roofs, that's your material carbon emissions. And then operational is anything that happens afterwards. It happens over a period of time. That's what you're used to accounting for your passive house, for example, your teddy. So typically we measure that in kilowatts per hour. I'll get into that in a second. But firstly, so we can get a bit of an idea of who's in the audience today, because we can't see you. We were curious to see who has done some embodied carbon or operational accounting. So I believe there's going to be a poll popping up any minute. There we go. So we're just curious to see if you haven't done anything, that's fine. Just say no. If you've done it previously on projects voluntarily, or if you've done it actually to meet a standard wherever you're designing. I'll give you a couple of seconds to answer those. There we go. So we got the results. I think you might be able to see them as well. If not, I'll just kind of outline it for everyone. So on both questions, we got very similar results. So the majority, almost 90, both had around 90% said no, that there has been no accounting at their practice so far, and then some 10% roughly said that they voluntarily accounted it before. I think that's not surprising because we don't have many standards yet. We'll get into that in a second. So usually it's on a voluntarily basis. So it's very interesting. Thanks for answering the poll, everyone. And just to talk about the last little bit here. So when you combine them, you actually get something called carbon use intensity. So that would be your operational and your material carbon combined. The little X you see behind CUI is a time frame. Because we're bringing in operational carbon, you always have to look at it over a period of time, right? You can't just look at it the first year, because there will be energy use intensity every single year. So we're making a bit of an assumption. We don't know what the energy grid is going to look like 15 years from now. And you can specify what that X is, depending on your project. If you're only interested in the next 10 years, that's fine. I've typically done 30 years in the past because that used to align nicely with the 2050 goals, but also most building materials tend to last 30 years. If you go past 30 years, you will probably have to account for some material replacements, right? So most building materials last around 30 years. So there will be a little spike in material carbon emissions once in a while for maintenance and replacement. And as I mentioned earlier, the units aren't directly comparable without converting them. So operational carbon, we're used to measuring it in kilowatts hour per square meter per year. In order to compare that to embodied carbon and actually create a CUI, you have to use a factor for your province. So since most of us in Ontario, I'm assuming, the carbon emission factors are down here. So for electricity and gas, they're a little different. So that'll obviously, not just a little, they're quite significantly different. It's 30 versus 107.7. That will vary by province. Again, Ontario is pretty good when it comes to the electricity grid, especially. Once you apply that factor to your kilowatt hour number, you'll be able to compare them and combine them. And then I touched on standards a little bit earlier. So we have, in Ontario, we really only have the Toronto Green Standard as far as we're aware. There's guidelines, but the standard is the Toronto Green Standard. So for operational carbon, all 3 tiers at this point have operational carbon standards, which is great. So even the mandatory tier, which is tier 1, has some guidelines here or some standards that you have to meet. You can voluntarily choose 2 or 3. And then for embodied carbon, there's nothing in the mandatory standard yet, but the way I understand it is every 4 years they scrap 1 tier and bring the next one forward. So I think the next one might happen in 2028. That's what I heard. So at that point, tier 2 would move to be the mandatory one. And then we finally get an embodied carbon restriction on it. So you'll have to at least account it. This number might not mean much to you. I'll tell you, it's not a very low number. It's a very easy to achieve number. The 350 kilograms of CO2 per square meter. But I think it's there to at least get us to think about it and to try out some tools and start accounting for it. It's not super restrictive. And then tier 3 is even a bit more restrictive, 250, which will come much later and will be voluntarily for a while. We do have some other standards and guidelines in Canada as well. Vancouver's usually pretty good with this stuff. They used to do 800 kilograms, so quite a significant number. They now narrowed it down to 360, so that's very similar to the Toronto Green Standard tier 2. And then Whistler has an emissions goal of 40% reduction. They have guidelines to achieve that, but there's no real targets at this point. And then we also have the Canada Green Building Council, which gives you a framework. And then, of course, you have various other, communities and institutions like NZAN, for example, the Net Zero Architecture Network, which will give you a framework and which will help you achieve your goals. As I mentioned, all those numbers are pretty large at this point. No one is trying to get you to a super low carbon building, which for reference would be around like 50 kilograms of CO2 per square meter. I think what this is really about for now is starting to get familiar with the accounting, starting to develop a feeling of what materials are good, what materials are bad, and getting an intuition, right? So most of us probably already know that concrete is a pretty big evil. It's a necessary evil often when it comes to foundation. But then there's other ones, like insulation and cladding, where you can really make an impact by choosing a low carbon alternative. These graphics are from Builders for Climate Action, by the way. They have a really great report on this topic. So if you're interested, just Google that. It's a nice read. It's not too long either. So when we get into the really deep accounting, which some of these tools you'll see later on in the case studies, there is 2 different camps that I like to divide them in. One is more of a budget estimate, and one is a very detailed one, which you would like to use probably later on, and especially for the if you need to meet any standard, you will have to use the more detailed ones. BEAM is, I think, the most simple one to use. It is actually done by Builders for Climate Actions as well, the ones that did the graphics on the last page. It's a very easy plug and play tool. I'll show you on the next slide what it kind of looks like. But it does only focus on material carbon emissions and only what happens during the production stage. Athena does both. It does the operational and the material carbon emission. So it's a nice way to combine it, but still keep it in a simple budget way. And then for more detailed ones, we have one-click and EC3, which they do get really meaty. I have a little picture of that later as well, so you'll see what that looks like. So this is the beam calculator. Again, it just has various proxies over here. It's all Google spreadsheet based, and then all you do is check off whatever you have in your project. So you would check off a triple pane wood window if you have it, and it would start counting that 74 towards your project. Type in your square meters, and it will spit out this at the end. So it'll summarize all your different parts of your building, and it will give you the overall score, which is the kilogram of carbon per square meter. So just remember the Toronto Green Standard will be 350 kilograms of carbon per square meter, which isn't even on Beams's rate, right? So it definitely is a very gracious cap for now. And then for the one-click LCA, this is what we actually used for our environmental product declaration at VETTA, because they do have a manufacturing and a professional-facing interface, so you can have two different products. And this is what it looks like from the manufacturing standpoint. Might look a little different from your standpoint if you get the product. I haven't seen that yet. But basically, you select every single material you have, you type in your kilograms and instead of square meters, which is a bit more accurate. And then you also have to type in things like transportation. So for us, for example, our windows are manufactured in Poland, but we get our handles from Germany. So we have to type in that trucking transport from Germany to Poland, right? So it goes a little further than Beam because Beam doesn't take into account transportation or anything like that. And then, of course, it would also take into account the transport from Poland to Canada. And these were the results from our EPD. And just a note, a lot of manufacturers nowadays will start doing their EPDs because it is being asked for, especially in multi-unit residential standards, not so much low-rise construction yet. But why we really did it wasn't so much as to have the EPD, which is great, but we mostly did it to actually make improvements. So we, for example, we haven't implemented it yet, but what you're looking at here is our transportation breakdown. So we use truck in the EU and truck in Canada, which is right here. And then we also use a container ship to bring it from Poland to the port of Montreal. And we assumed that the container ship would have been our, biggest carbon enemy. But it actually isn't, because of the amount of containers that are on a ship. It's actually such a small percentage that the trucking in the EU is actually much larger. So this takes up 12% of our total carbon footprint. The trucking in the EU, which is really not a long distance, is much, much more. And the trucking and rail in Canada that we use is actually equal to that entire stretch of sea container. So, we didn't realize that before, and we're trying to now scale down our trucking operations a little bit. A1 to A3 is your manufacturing phase. So that's anything that happens at the manufacturer, at the raw materials, so the wood, the aluminum, the glass, all of those things. And then now that I set you guys up, I will pass it over to Brad.
All right. Hello, everyone. My name is Brad. I am an architect, sole proprietor of Brad Tapson Design, working in the residential field and sustainable architecture. I'm going to walk through a couple of different sort of case studies of some projects that we've done in the past couple of years and different approaches to this sort of low carbon design mindset. Let's just see if the slides work here. There we go. So the most important thing in my mind is to understand why we're trying to do this. And Kim did a great job explaining the differences between sort of embodied carbon and operational carbon. For a long time, traditional practices or measuring systems have been worried about operational carbon, not so much about embodied carbon. So, you can build a passive house out of steel and concrete and spray foam and glass, and it'll perform really well, but the amount of sort of energy invested in that building is so high that the payoff is never really going to happen in a manageable way. So understanding if we're trying to build more sustainably, we need to be thinking holistically. So we need to set, clear priorities, clear vision, make sure that that's communicated and agreed upon by the whole team. Also understanding, especially in the scale of work where I operate with individual homeowners and a lot of renovations and things, not always able to go as far as we might want to in an ideal world, but there are always ways to make projects more sustainable. It's really important to understand the systems that we're using and putting in place. And I'll get into that in a little bit, but sometimes subbing out one material for another can make a drastic difference in the overall performance. And ultimately just finding the right approach for every project, including renovations. So first case study I'm going to look at here, if the slide changes. There we go. Prefab top-up. So this was a project, a bungalow in Scarborough. Young family needed a little bit more space in their home, didn't ever want to have to move again, and really just wanted to focus on building a sustainable long-term residence for their family. So we looked at adding a new second floor and then improving the existing home as much as possible. The big question is how to ensure the quality of high-performance work with tight timelines and budget. So in this case, we found the right partners. We looked around and we ended up going down the prefab route and partnered with, in this case, a company called Simple Life Homes. There are a lot of different prefab companies out there. I won't necessarily speak to, which ones are good or not good. But in this case, the values of the company aligned really closely with the values of the clients and the values of myself. Focus on natural materials, focus on permeability and breathability of the wall systems, high levels of insulation, high levels of air tightness, and all of that, in this case, able to be delivered on one truck and put up in a single day. So all of the second floor framing that's there and the roof went up it was a long day, but it went up in one day, which was great, and then allowed the rest of the project to continue. So in this case, obviously, we kept the masonry of the existing basement and ground level and then added the new second floor. We've got insulated roof panels for a conditioned attic, which allows for storage and also for transition of mechanical equipment and things like that. It was important to figure out how to tie in the new second floor to the existing sort of first floor. In this case, it was kind of a full gut, so we were able to install new membranes and things on that first floor and then tie in nicely. So we increased the insulation value of the main level and the air tightness of the whole home, and the performance has been just fantastic. So we found the right partners. We kind of foolproofed the project in a sense because the wall panels were built in a factory environment. We know that the quality is up to a level. And then in this case, the contractor who came in to finish the project and to sort of work with these wall panels that had been installed wasn't necessarily terribly experienced with high performance building materials or methods, but sparked their interest to the point that now they're getting recommended to me by people who don't know that we've already worked together as someone who is doing good work in this sector, which I think is great. So, the clients are happy. They've got a very efficient, very comfortable home. It sparked a lot of conversation in the neighborhood, and it was done very efficiently, I think, in terms of the build and the result. Second case study is more a case of what not to build. So in this case, a typical sort of East York semi-detached home. Again, a young family needs more space. They came to me with an idea in mind. They had tried to look at a bigger home and been priced out of the market. So they wanted to sort of reinvest in their current home. They love the neighborhood, all that stuff. So they came to me with ideas of doing a third floor top up and maybe a front addition of the porch and maybe a rear addition and all these things. And when we got talking, it was, it became clear that their dreams and their budget didn't align. But what we did was a really thorough sort of program analysis and sort of lifestyle analysis, and tried to determine what do they really need. So we went through a couple of different iterations of the design. On the left there, we've got, a third floor addition and a bunch of changes. And then on the right, a much more modest sort of adjustment with a small rear addition, that when we got into it and when we started looking through it, actually solved all our problems. So we went ahead with the rear addition. It's under construction now. It's a very modest size, so it fits in the budget. It reconfigures enough things that they're going to be very comfortable in the home. All of the new work is being done to a high performance level and tied in as best as we can to, the scope of work within the existing home. So again, in this house, it's not sort of a deep green retrofit of the whole home. The new work is done to the level that we want. We've also made some choices like using helical piles for the foundation instead of excavating and using concrete. So that minimizes the carbon footprint of that foundation, which is such a heavy use area sometimes. Yeah, so ultimately, this is a story of sufficiency. It's deciding what's the right size and what do we need to do, and not necessarily, going as far as they had originally planned, but finding solutions that work within their means. And then the third example here is a new build. In this case, it was a laneway suite that was done fairly early after the laneway suite bylaws came in. The clients came to us before purchasing the home and looking specifically for a place where they could build a laneway suite. They found this one in the East End that had quite a hill on the site, which allowed for some really creative sort of options in the laneway. But ultimately, it was how to optimize the site, how to create something new really efficiently within a really tight urban package. So in this one, we started to explore some of the tools that Kim talked about a little bit, and started to look at the building assemblies and what we could do to make those really efficient. So I've got three sort of modeled here. On the left, something we're all very familiar with, the code minimum wall assembly. We've got the pink stuff in the wall. We've got the building paper, the plastic poly vapor barrier, foam insulation. This is the code minimum. I talk to clients all the time and I say, this is the least that we are legally allowed to do. And that doesn't seem very appealing often to people. So there's a lot of reasons why we want to sort of evolve from this. In the middle here, we've got something that I've called the operationally efficient wall. This one takes into account the operational energy, operational carbon, and is a very airtight, very highly insulated package. But in this case, it's got spray foam, and it's got a foam board here on the outside, and doesn't necessarily take into account the embodied carbon aspect or the embodied energy aspect. So it performs well. It's easy to build. You can see why people do it. But when we think about that whole package and when we think about the why of what we're doing, we start to see that maybe it's not the best way to go. And so on the right, we've got what I've called the carbon conscious wall. So in this case, you need to maybe go a little thicker to get the same amount of insulation, but it allows for, dense packed cellulose in this case, which is not only lower carbon, it's actually carbon sequestering, even at the scale of a house. We've got smart permeable membranes on the inside and the outside, so there's no plastic vapor barrier trapping moisture inside the wall. We've got walls that can sort of breathe and dry out to both sides. We've got a service cavity on the inside, allowing for that membrane to maintain its integrity. So when you hang a picture, when you put something in your wall, you're not poking a hole through your air barrier. So just sort of foolproofing the system, building in a way that is performing well for a long time, and thinking of this whole wall as a system. So we plugged those things into the beam calculator in this case. So on the left is the operationally efficient wall. On the right is the carbon conscious wall. It's hard to see the details here, but when you look at the slides later, you'll be able to see the biggest thing here in part was the roof. and the exterior walls. The foundation is what it is. In this case, it's built into a hillside, so we couldn't look at something like helical piles, but we tried to minimize where we could. But in this case, the exterior walls have gone from quite a high sort of carbon footprint to actually swinging to the negative. They are sequestering some carbon here, which is amazing. The roof going from a really high sort of level here to almost nothing. I think it's, from 9,000 down to 18 kilograms or something. And that's, again, using cellulose in that roof assembly, switching up some of the materials and things like that. So it's taken the overall sort of carbon footprint from high down to low here. So again, it's not necessarily, the driving force, or this tool doesn't necessarily need to be the driving force in your design, but it should be one tool in your toolkit to help make some decisions as you're proceeding. Like, you're looking at the cladding and you want to say what way should we go, or the insulation. There's a lot of things to take into consideration. There's aesthetics, there's cost, there's durability. Carbon should also be one of those things. So there are tools out there to help us do that. And I recommend everyone grab that beam calculator and play around with it and start seeing how it can help you in your design process, because it can really make a difference when you're making those decisions. And so the result is this beautiful, compact, efficient home, a new house in Toronto on a reasonable budget. And the clients are very happy and very comfortable. So I think with that, I will pass it along to Chloe. Ooh, sorry, not too far. There we go.
Hi, everyone. My name is Chloe Doesburg. I'm an architect, but I'm also the co-founder of Seafoam. We're developing regenerative carbon storing building insulation from seaweed and upcycled waste. So I'm really passionate about finding ways that we can turn the built environment into a climate solution. And during my research developing a building material, I've learned a whole lot about how the materials we use contribute enormously to the overall carbon footprint of our build projects. So this is the material carbon emissions, the embodied carbon that both Kim and Brad have spoken about. And there's products available today, again, some of which Brad has mentioned on his projects, where we can make a simple material swap that has a massive impact. So that's what I want to talk to you about today. Oops, went too far. So building materials account for 13% of total global carbon emissions. And as Kim already mentioned, more than 2/3 of those emissions come from 3 categories. So that's cladding, insulation, and concrete. So as architects, what should we do about it? I think the good news is that we have a lot of influence over material selection, which means that we have a lot of opportunity to make an impact. And I'm going to break down how we can do that into 3 key strategies. So there's reuse, use less, and use plants. First up is reuse. So obviously the most sustainable building is the one that already exists. But of course, there's lots of situations where adaptive reuse isn't going to work. We need to demolish buildings. In these cases, don't demolish, deconstruct. So deconstruction for material salvage and reuse is a growing practice, and I want to highlight one firm that does exactly this. If you have a project in the GTA with a portion of a building or a building that needs to be demolished, especially at the single-family home scale, consider reaching out to Ouroboros Deconstruction. They'll come, they'll be your demo crew, but instead of demolishing the building, they'll dismantle it carefully and resell the materials that can be reused. So, of course, that makes them also a great source for reclaimed materials. You can check out their website for reused doors, windows, flooring, hardware, lumber, and more. You can also contact Meredith, their CEO, to get information about what materials are coming available. So reclaimed materials are a great way to lower upfront carbon, but the logistics of efficiently sourcing and accessing those materials can definitely be a challenge. And that is exactly the problem that this company, Green Salvaged Materials, exists to solve. So they do 2 things. They have something called the Reuse Collective, and they also have a material marketplace. The Reuse Collective is a member network, so your firm can join this network, and by being part of this network, they help you embed circularity practices in your organization. So this will be designers, builders, and others in the industry. And they work with those members to help them integrate reuse into their specs, into their design, and into their workflows. So by joining, you not only have a great opportunity to lower the carbon footprint of your own projects, but you're supporting the building industry's capacity for reuse. Obviously, when we want to be circular, we all need to work together and sort of participate in the same material flow. And they also have a materials marketplace. This offers materials coming from existing buildings, manufacturing surplus, and post-construction supply. They have a particular specialty in masonry and stone, so it's a great place to get reclaimed brick for cladding. Or reclaimed stone. So consider joining the collective and reach out to source salvage materials for your projects. Okay, the next solution is use less. And I think this one applies in particular to concrete. You can, in many cases, modify your design so you need less of it. Brad gave a great example of that in one of his projects, using helical piers instead of a concrete foundation. Uses a ton less concrete. Maybe you don't need that basement. So I think that we can modify our designs like that in that example. And we can also just make sure that we're using concrete efficiently. Sometimes this requires talking to your structural engineer. Sometimes we can do more with less without making a massive design change. We can also substitute other materials for concrete in a whole lot of places, sometimes where we don't think we can. You can use it for stairwells, elevator shafts. Mass timber can obviously replace concrete in a lot of structural applications, and even in below-grade applications. There are people working on using wood as an alternative to concrete. And lastly, when you do need to use concrete, make sure you're specifying concrete with a high percentage of supplementary cementitious materials. This can reduce the associated emissions by up to 30%, and these are materials that are generally widely available. So talk to your structural engineer. Quite possible the engineers you're working with are already doing this, but make sure they've got this in their specs. And you might wonder, how much are these changes going to cost? So this is a fantastic chart that shows that you can often achieve significant emissions reductions without adding significantly to the cost. So this is true for concrete, structural steel, rebar, drywall, and insulation. Obviously, it depends on which products you're speccing, but those alternatives are out there. And I will talk a little bit later about how to find them. Okay, so the last strategy for how we can reduce our embodied carbon is to use plants. So this one is my personal favorite. Plants are the original carbon capture technology. They draw carbon out of the atmosphere. That's what we do. That's what they do. And so when we make materials out of plants, if we're doing it in a careful and thoughtful way, they can actually be carbon negative, like the cellulose insulation that Brad mentioned in his product. That means that they store more carbon in the material themselves than is emitted during their manufacture. And while wood can often be a fantastic low carbon material, we have to be very careful when we try to use that as carbon sequestering, because it has to be paired with really sustainable forestry practices. But if we're talking about plant-based material from agricultural waste, from waste fiber, and from rapidly renewable fibers, then there's even greater potential for carbon storage in buildings. So this diagram talks about exactly those kind of fibers. This is waste wood, waste paper, and agricultural waste. And as you can see in this diagram, there's already a ton of ways that we can use these biomass feedstocks in building products. So some of these products that you'll see in this diagram probably aren't things you can go out you can't get at Rona today, like recycled concrete studs, but there's a lot of work happening in this area. So I'm hoping certainly a lot more of these products are going to be available shortly. But some of these products you can absolutely go and get at Rona today. Again, cellulose insulation, engineered wood flooring, bamboo flooring, linoleum, all of these have the potential to be carbon storing. And the impact, when we think about what that could mean at scale, is truly massive. So these numbers are from an American study, but certainly the concepts translate well to Canada. So the potential for impact at scale is just massive. In a low adoption scenario, 100 million metric tons of CO2 equivalent could be stored in new homes over the next 25 years. We're planning to build a lot of homes, so doing this in a way that doesn't exacerbate the climate crisis is possible and within reach if we do it thoughtfully and if we do it right. And there's also a ton of underused biomass. In the US, 400 million tons. So that's waste wood, waste paper. I mean, forestry industry has tons of waste wood that is generally just burned or composted. If we can find a way to put that into buildings, that carbon is stored rather than returning to the atmosphere. Okay, so now let's talk about some specific bio-based products that you can use today. I'm going to focus on insulation since the emissions associated with that are second only to concrete in the residential sector, and because there's a lot of opportunity to take that high emitting product and replace it with one that's carbon storing or carbon negative. So in the wood fiber category, there is continuous exterior insulation that's manufactured right here in Canada, in Quebec. There's also timber HP products. These are manufactured in the US. They've just kind of got their plant ramped up and online in the last few months. So I think we can expect to see these products in Canada soon. And those will be cavity insulation, continuous exterior insulation, and loose fill. And cellulose insulation, this one you'll recognize from the hardware store. Extremely easy to source, tried and tested for decades. It's affordable, and it can be used in cavity walls, as Brad mentioned, as dense packed cellulose in the wall, and as loose fill in attics. And fun fact, when you replace conventional insulation with carbon storing cellulose, you can see on average around a 20% reduction in the embodied carbon for the entire home. So that's one material swap to make a massive, massive impact. And sometimes some people don't like working with cellulose because it's loose fill and it can be fussy to install. But I'm really excited about this new product, cellulose bat insulation. So Suprema has just purchased a company called New Wool that makes a cellulose bat. It's currently undergoing the testing for use in Canada. So I hope to see those on shelves soon. And hopefully, yeah, if you spec it today, will probably be ready to go in your project by the time it's rolled out here. And then hemp insulation. We also have hemp insulation manufactured right here in Canada by Nature Fibers. That's made in Quebec. And south of the border, Hempatexture does the full line of hemp-based insulation, board, bat, and loose fill. So yeah, check those out. Definitely, this is some stuff you can put in projects right away. And the residential sector is a great opportunity to use these products because it's non-combustible construction. Not all building types have these options. So when they are available to us, it's a great opportunity to use them. And here are two fantastic resources to find low carbon materials. If I could talk all day, I could tell you about a ton more, but rather than do that, I'll just point you to two resources where you can search for the types of materials that you're looking for. So the first one is the Builders for Climate Action Material Database, and the second one is the Healthy Materials Lab Material Collections. Both are searchable. I'll put links to both of them in the chat. Just look, you can sort by material category and see a list of low carbon options for you to choose from. And lastly, if you're interested in learning more or helping to drive change towards a sustainable built environment, get involved. You can join the Net Zero Architects Network. And if you're particularly interested in tackling embodied carbon, check out the Carbon Leadership Forum. They've got amazing resources, and join the Bio-Based Materials Collective. These are international groups that are doing fantastic work and creating fantastic resources. So it's just really inspiring to see all of the work that's happening in this space. And I think on the embodied carbon front, our awareness of it as architects is changing quickly, and the material availability to support that change is also changing quickly. So that's it from me. I will turn it over to Carolyn.
Thanks, Chloe. Really exciting information so far. I'm just making, oh, there we go, it's working. So I'm Carolyn Moss. I'm the principal of Moss & Architects. I've been in practice for over 20 years now. Starting off at Carleton, I built myself a little solar studio out of reclaimed materials. This is a long time ago, but this has been a passion forever. I'm also founder of a company called Homes to Zero that I'll speak a bit about at the end. So I'm just like, right. There we go. So as a firm, our goal has always been to reduce the environmental impact of low-rise residential building. And like we've all talked about, we have such an opportunity in buildings. We've known about how energy efficient our homes are for a long time, but we have to build a lot of homes in Canada. And the next 10 years are really critical, because if we were to build all those homes in the traditional kind of spray foam or, you know, foam siding with brick, we're going to have a big problem because of the amount of emissions that are created by the materials to build those homes. Is going to be a huge contributor to climate change. So I really encourage everybody to start looking at their projects with a new lens to say, how can we do better? The thing is, I don't know if everyone else is in the same boat, but low-rise residential, the fees, it's really hard. You're not going to be able to do, or in the past, we haven't found that we're able to do, for example, an energy model for every single house, or to do a beam model for every single house to measure that embodied carbon. So what we've done as a firm is that we've taken the kind of typical construction that we use, and we've tested that as a base case to say, okay. And so we used to do this with our wall assemblies and envelope in general. And we'd say, okay, here are the assemblies that we usually use. How can we make it a bit more energy efficient? How much impact, for example, this is like 10 years ago, we said, okay, if we use a certain kind of double glazed window with high performing glass, how is that going to compare to a triple paned window? And what was the cost difference? And at the time, triple glazed windows were really expensive, and the extra cost involved in buying a triple glazed window compared to that double glazed window wasn't really justified for the amount of actual energy that it saved. So we would, you know, try to take that budget and use it in some other way. So we've been always testing those envelopes as we've moved along, not for each project. We'd find one that really worked for that time, and then we'd use that for a while. And then as the industry changed, maybe every 5 years, we'd test it again and say, what can we do? And so now we're doing the same thing with embodied carbon. We took those typical assemblies we've always been using, and we said, okay, how can we make them better in a way that's cost effective, we can build with now? And then we use those. And we tweak them as we go along, but we're not reinventing the wheel or having to do a whole model for every single project. So in our mind, the question is really, is close good enough? And right now, when there's no standards that we have to meet, we're just trying to do the best that we can. You know, we don't need an actual number, so we feel that close is good enough. So some of the strategies that we use, these are embodied carbon kind of related, but like Brad had mentioned, first thing is to right size our buildings. Smaller, smarter floor plans will cut your materials, they'll cut costs, they'll cut the lifetime energy. So in Canada, average square footage per person in our homes is 72 square meters, about 785 square feet per person. Whereas in the United Kingdom, 33 square meters. And in Hong Kong, 15 square meters. So we don't need to go down to 15 square meters. It's not likely going to happen. But can we live in homes that are, say, 500 square feet per person instead of 785? How can we look at the size of the spaces that we're living in, make them smarter so that, you know, it reduces their environmental impact? So that's number one strategy that we look at. Second strategy, the biggest thing is to electrify. The biggest source of emissions in our buildings is the fuel that's used to heat and cool them, and for hot water. So the burning of fossil fuels, we just eliminated that. No more natural gas for cooking, for heating, for hot water, for anything on site. All our buildings are now electric. and as high performance as we can. We use heat pump hot water if it makes sense, induction stoves. But that is definitely before you get to any kind of material selection, before you get to embodied carbon, you have to electrify. But then we're going to be building these buildings, and how much energy it takes to build them is really critical. So we're choosing our low carbon assemblies and finishes. Resilience is also very important, because the last thing we want is to have buildings that have to get replaced sooner. So we have to make sure we've got good eaves, we've got good flashings, so that that building's going to be around for a long time. And then, only then do I get to energy efficiency. And so of course I want to have a really airtight structure. We're going to have a great envelope with good levels of insulation. And really good equipment. But really, as you can see, that's kind of far down on the list of importance in terms of carbon savings for us. And then last on that is renewables. And I wish there was a zoning bylaw that made this kind of required, but designing our roofs for solar, I think, is really critical. Thinking about where your plumbing stacks go, where your vents go for your attic, so that you have a clear south roof. It's like something I think is really important for us to think about as well. So getting into the embodied carbon part, I gave myself a project, a goal on this project, which just so happens to be my own, so I could test things on myself. This was in addition to a 1956 little cabin, and my goal was to make it achieve passive house and see how low we could go in terms of embodied carbon. So we chose low carbon materials, and just so you understand, it's about a 900 square foot addition, 1 story, and it has an exposed floor. So I'll just, sorry. We did the PHPP model, the passive house model first. Like, you have to do that before you start building. I didn't do the beam calculations until later, but so when we're looking at passive house, I don't know if many people here have done a lot of passive house structures, but to achieve passive house with a 1-story structure with an exposed floor is very difficult. We had to go with R100 in the roofs and the floor, R60 in the walls. We used a double stud wall with cellulose, packed with cellulose. We had R10 windows that were passive house certified. We are well under 0.6 air changes per hour, no thermal bridging. It was so tight that we actually could only use an HRV, not an ERV, because the ERV used an infinitesimal amount more energy than an HRV. So we were really chasing this energy use. You're required to have meet 15 kilowatt hours heating demand. The whole demand for this building was 53 kilowatt hours per meter squared per year. That comes out to 3,800 kilowatt hours. And so I don't know, like, I use these numbers all the time. For those who don't, a typical house that runs on electricity would be using about 16,000, 17,000 kilowatt hours per year. And so the greenhouse gas emissions. So a typical house in Canada uses 5 tons of emissions if they are heated by gas, 5 tons of emissions per year. An electric house, just for the means of not burning fossil fuels on site, is usually 1 ton or less. And this project was 0.1 tons of greenhouse gas emissions, which I've just transferred into kilograms because that's how embodied carbon's usually measured. So the operational carbon use intensity on this project was 1.5 kilograms of CO2e per meter squared per year. And if you remember back to Kim's slide, the tier 3 target was 5 kilograms, and tier 3 is the highest target from the Toronto Green Standard. So this house was very, very energy efficient. And then looking at the embodied carbon, again, we'll talk about this. I think I went you had to meet that passive house, to chase that very low energy standard, we had to use a lot of insulation. And so we did, like Chloe talked about, we reduced the amount of concrete that we needed. We used piers instead of a full foundation, both to reduce concrete and because we wanted water flow on the site to stay the way it's always been, or to not impede it. We eliminated materials where we could. We used wind bracing instead of sheathing. And then we used bio-based materials. So it's all wood frame construction, cellulose cavity insulation. We had wood fiber rigid insulation, wood siding, wood windows, plywood interior finish. There's no drywall. Local pine flooring trim, and the ceiling, it came from about 60 kilometers away, and linoleum flooring. So the result was just over 2,800 kilograms of carbon sequestered. And that's minus 39 kilograms per meter squared. And typical residential projects are between 150 and 210 kilograms. And then that tier 3 standard, the highest standard, was 250 kilograms. So this house, again, is carbon negative and very low energy. And the thing that I find interesting is that to meet passive house, I just had to put more and more and more insulation in. And at some point, in my mind, I think I could say this is my project. It's too much. Like, I would have rather used less of those bio-based materials, get this to a 0 carbon, and then give that to somebody else who was planning to use spray foam, right? I think there's a right size, like a right scale for the amount of material that you're using and how it's being used. And it really depends on the size and shape of the project that you're doing, and what it's just not, yeah, this was looking at what can we do? It's like, then what should we do after that is the thing that we're really interested in looking at our firm. But as a comparison, I think we had, Brad had mentioned this as well, is we could have built this also meeting the passive house standards, exactly the same levels of insulation, but we could have used a full ICF foundation. We could have, I didn't go too crazy. So we still use wood frame construction with plywood sheathing in this. So this is taking that exact same building, changing the materials out. If we had used spray foam insulation, aluminum siding, aluminum windows, a steel roof, a mixture of drywall and plaster interior finishes, really fancy engineered hardwood flooring and natural stone in the bathroom areas, this project would have been over 34,000 kilograms. So 34 tons of carbon, or 475 kilograms. Again, that is, you can see just by changing the materials, what the difference is. And so this is like the worst case scenario. Well, actually it's not. If we had used brick or something, which we wouldn't have done at a cottage, but it would have been even worse. But it's just showing how you can change your materials and make such a big difference. And then what if, like, what's something in between? So here's maybe if we didn't quite go passive house, we used a bit less of insulation. Maybe we still had a full concrete block foundation, maybe wood frame construction with zip sheathing, fiber cement siding, maybe vinyl windows, asphalt shingles, fiberglass batt insulation, mineral wood rigid insulation, a drywall finish, engineered hardwood, ceramic tile. And that's not like a crazy, super eco-friendly building that we're looking at here, but that's at 159 kilograms. So this targets of 250, that's very easy to meet. So like very typical changes can help you meet a lower embodied carbon. So again, these are all using the beam calculator. The beam calculator just includes the major materials. It doesn't include like your faucets and what kind of handles you use on your doors. It's really looking at the very big picture items that are going to be the thing that really are driving your embodied carbon. So we took this information that we had learned from the cottage edition and said, okay, can we just use that same information and put it into an actual project. And so we were able to do that. We achieved a low embodied carbon and operational carbon. This is in addition to a student residence at a private college. We just specified standard wood frame construction, a bit deeper than normal. We used cellulose all electric systems. We educated the client and the contractor on the air changes per hour, on getting a good air tightness on the building. And we used a really great product called Glavel, which is like sub-slab insulation and gravel. It acts as both together. It's a recycled foamed glass material. We used, again, just like a bit bigger trusses that we could get a bit more cellulose insulation into. We had a really great envelope designed and executed by the contractor. But the result for this was 79 kilograms. So really on that low end of the scale, 55% reduction over typical residential in embodied carbon, and 95% fewer emissions than a typical residential construction. So, and at no extra budget, like no extra budget, same price. So as we've all talked about, we're big fans of the Builders for Climate Action. They've got some great carbon emission guides. They've got their beam calculator. We also use PHPP a lot to just test different assemblies and see how that's going to affect our energy use. We use HOT 2000. It's got some assumptions in it that are going to make it inaccurate, but you can still use it for comparison. Homes to Zero is if you're looking at what the annual energy use and greenhouse gas emissions from your house, you can go onto the website and put in how much electricity and gas or wood or oil that you used, and it will tell you what your greenhouse gas emissions were. It's a really good tool to be able to quickly understand what the emissions were from your building. The OAA, of course, has a TUI calculator that does building carbon and energy footprint calculations. Also, I think it's really important to get the word out. So we've been developing case studies for ourselves and for clients. And so the OAA has case studies on their website. Retrofit Canada is really trying to develop case studies for residential projects. They're gathering those. There's also another company called the Zero Energy Project. And I think it's a great way. If you're doing good work, we should share it. And it's a good way for people who want to learn more. They can go and look at the case studies. But if you're doing a project that you would like to, that you think should be showcased, then it's great to get it onto these websites. So, so as I mentioned at the start, I'm both an architect and I founded a company called Homes to Zero. And we did that, again, because we're just trying to make it easier and faster and less expensive to plan low carbon retrofits. And we know that if we're working on one house on a street, there's like another 20 houses on the street that are basically the same kind of house and might have a very similar solution on how it should be upgraded to be better for the environment. And so we're trying to help homeowners and contractors, designers, to get better information on how their home can operationally be net zero, how they can have better envelopes, lower their embodied carbon. And then we're also working, because I know in my own firm, I had this problem. It's really hard to get to, you know, doing that, the work needed to prepare a case study or do the models, right? It takes a long time. So we're doing this for other designers and contractors. We're putting together case studies based on projects that they've done already. So you can reach us through homestozero.com if you're interested in having help in starting yourself, like your own firm off, in how to do better on your own projects, or again, get that case study out. So thank you. Kim?
Thank you so much for this wonderful presentation. Now we're entering our Q&A portion of the webinar. So just for those of you who are on the call, you'll see again, there's a button at the bottom of your screen that says Q&A, and that's where you will type in your questions for the speaker. So we've already got one question, and it's from an anonymous attendee. It's directed to Brad, but feel free if there are any other thoughts from the panel. Would you consider staggering studs or better horizontal installation for the carbon, in quote, carbon conscious to reduce the thermal bridging? It may just be a service chase. I don't know what that's referring to, but I'm hoping you do. But airspace and GWB is part of the R value. Reduction of thermal conductance is important as well.
Yes. So yeah, absolutely. Part of this sort of work is understanding and knowing that this information is always evolving a little bit. You know, we don't, you can't just get sort of stuck in your ways and think, well, this is the way to do it. We're going to do it. As new information comes out and as new sort of best practices become available, we need to evolve a little bit. So definitely, you know, making sure that you don't have one continuous thermal bridge is important. So yeah, different ways to install that service cavity are good, or maybe, you know, that diagram showed quite a deep stud. It's like a 2x8. So rather than that, maybe do a double stud wall with a continuous sort of gap in between to allow for insulation to fill that gap. Yeah, so definitely other ways to look at that, and those are evolving as we continue designing.
Yeah, it's interesting. The two projects that I showed are both more rural projects, and so the one had about a 20-inch thick wall, which if you're in downtown Toronto, you are not going to be using a 20-inch thick wall. It's just not feasible for the amount of space that we have. So you have to figure, how can we, like, that's the double stud wall, obviously has the gap in the middle. And so staggering a stud is another good way to make it so that you're eliminating the thermal breaks from it. But, you know, the requirement now for continuous rigid insulation is going to take care of, is going to help a lot.
Yeah.
So, but, you know, staggering a 2x4 instead of going with a 2x6 or 2x8 wall is certainly an option if that works in your case.
Right. The next question actually I had in mind as well, and I think Carolyn, you'd mentioned that none of these requirements to calculate carbon are currently mandatory through our legislative framework. So the question from Calvin, and also for me, is: are there any other jurisdictions that are bringing forth mandatory requirements? Are there any other jurisdictions that we can really look to as models, maybe for Ontario? And yeah, if you can kind of give us thoughts on that.
I think Kim talked about it a little bit. There are already standards in Vancouver. And certainly, Kim, did you find any other?
No,
I think there's an
in Ontario, it's really only the Toronto Green Standard, which currently the embodied is voluntarily. And then Vancouver has the mandatory standard. That's all I was able to find.
Are you aware of like any work being done in terms of getting this change put forward, or do you have any thoughts about, even if it's a good thing, like do you think it would really help, or create other issue? Obviously, any change is going to come with the good and the bad, right? So any thought?
I do think that there's standards coming, like in the States, they're working on them. I can't name offhand, but I'm pretty sure there are places that have embodied carbon standards already. We're pretty focused on Ontario at the moment, but we got to get my head out to see what the broads, and in Europe as well, they're looking at them. And I think it's actually absolutely critical. Like I would say embodied carbon, like we talked about, is more important in a way. I mean, operational, we know how to do it pretty easily, but the amount of energy difference you can make just by changing materials out, because of the amount of housing that needs to be built in the next 10 years, if it's built with foam and brick, it's a problem. And so those are like, if someone was asked me what the big things, I think there's the big three, but really no foam, no brick. It's gonna be really critical for the next 10 years to be really looking at embodied carbon, even if there's a standard or not.
Right.
I'll just add one thing to that. The Carbon Leadership Forum does have a policy tracking map where you can see the embodied carbon policy globally. Not as much as we'd like to see in Canada, but certainly I think in Europe there's more. I'll put that link in as the answer to this question if anyone wants to check it out.
Right. Okay, there's a few more back from the broader analysis and some more specific questions. A question from an anonymous attendee is asking, he says he or she is working on many compact older homes in Toronto that are typically load-bearing masonry. Is there a low carbon insulation assembly that you would recommend that doesn't significantly impact interior space? So again, you can't give professional advice here, but just that maybe your thoughts on things that have worked well for you in your context.
I'll just go quickly. The first two slides that I put up at the beginning of our presentation were projects that we did a while back, and they were done at the same time, and friends actually. And the one client, they hated the outside of their house, their brick house. They just did not like it. So we overclad that house. And so that's, you know, especially in the compact Toronto homes, if you're able to overclad, it's a great solution. The other house was getting fully gutted anyways, and we were able to insulate on the inside. The outside insulation version, in terms of having, you know, reducing thermal bridging, etc., is really the best, is the best way to reduce thermal bridging. But at the same time, it's, I think, Kim, you've done quite a bit of work on this in the energy budgeting to see how much energy, and I think this is something we have to keep in mind always, is how much energy is it going to take to use the material, to put those materials on your building, compared to how much is it going to save over the lifetime of that renovation. And if you're choosing like even mineral wool, it's going to be a tough justification to insulate.
Yeah. I know there are like the Simple Life Homes, the prefab company that I worked with on the example project. They are doing some overcladding projects now, so prefabricated high performance overcladding. I don't know the details on that, but it is something that they're working on. But yeah, in terms of interior insulation, it's tricky balance, because A, you don't want to lose too much space, and B, if it's structural masonry, you don't want to compromise the integrity of it by creating, you know, a highly insulated and sealed condition on the inside, where now the brick could, you know, it's understanding that system in with different components and how it needs to all work together. So I feel like I remember talking with somebody, I think it was Sarah Grant from Goldfinch Energy maybe, or they'd done an analysis and found sort of an ideal R-value range for interior insulation on brick homes. Anyway, I need to look more into that. Don't take that as gospel, but yeah, I mean, I've used products like sheep's wool insulation as a bat, which was interesting. We did have to get a building code sort of, what's the term, alternate solution clearance for that one. I haven't used hemp. I saw someone mention that, but yeah, there are some, you know, lower carbon insulation products you can use in interior conditions like that. It's finding the right balance.
Right. Yeah, I mean, it's important to know, this is why people hate lawyers, because we always say it depends, but I think it's really important to remember, right? Every context is going to be different. The climate's going to be different. Yeah, so looping back to that question, and this is, yes, my question too would be, would fiber and hemp support mold growth? I'd be concerned, so Scott is asking, he's saying he'd be concerned about using it on an exterior wall. his mantra is to keep the water out, and assume you will fail. So I also know that's the biggest claim, right, for water damage. So any thoughts on?
I can answer this one a little bit, and I'd love to hear, other people's answers based on their personal experience. But I mean, all of these products undergo testing, that mold growth is one of the criteria. So I wouldn't assume because it's bio-based that it's more likely to support mold growth. I mean, fiberglass absolutely supports mold growth. I've been on lots of sites where the walls are opened and, it's not great in there. So I think that I would definitely recommend a vapor permeable assembly when you're using a bio-based insulation. But I wouldn't assume that because it's bio-based, it's more susceptible to mold growth. There's also lots of issues with spray foam and mold growth where it's not the insulation itself that's, supporting mold, but because vapor is trapped in other building layers, like your sheathing may be moldy. So
Yeah, the health implications, generally, I think what the people who look into this is that we know that the natural based materials are also typically healthier materials. And so there's mold is one thing, right? There's also like what happens when they burn, like a spray foam. If you're in a spray foam burning building, it's a real problem. Whereas these natural fibers do not burn at a higher rate than spray foam. Like spray foam is really toxic when it burns, and burns very quickly. So there's a range of things, but I think the question for sure you want to make sure is that resilience is built in, and that you have to go after like the layers of your building. And the first thing always is to shed water properly, right? That's like the number one thing. Shed your water, you want then airtight, then your thermal performance, and then your vapor performance. And so you've got to always make sure that you're getting water away. Absolutely.
Right. Okay, the next question is about eco-friendly roof products. Any thoughts on roof products?
Yeah, if I could have put cedar shingles on my roof, I would have. It's also a balance, right?
Yeah.
If you could, like steel, it's good for durability, not great for embodied carbon. Asphalt shingles are better, not great for other reasons. So it's a tough one. Anyone else have a good solution?
I was going to say that durability ends up often being the key factor in that discussion, where if you can get something that's going to last for a long time with minimal maintenance and is going to perform at the same level, the whole way through, that often tips that balance.
Mhm. Yeah, cedar is beautiful, but it's a lot more expensive, I guess. That's the other factor, of course. A lot of these things are, right? Yeah, someone's asking about, and you did touch on this, the plant and wool-based insulation on the fire-rated systems. So it was interesting, Carolyn, to hear you talk about the way that spray foam and those materials burn. Can you speak specifically to the have they been tested, the wool or the plant-based materials with fire rating?
yeah, there's certainly some, sorry, I'll jump in quickly, but there's certainly some of the bio-based materials that have been tested for fire resistance by CCMC. So cellulose, I think, has class 1 fire rating, so does wood fiber. I'm not as clear on the others, but I would suspect it's comparable. And I think anecdotally, I've seen some cases of houses with dense packed cellulose performing extremely well in fire conditions. So again, I think it's more of a perception that bio-based materials are more susceptible to fire. I mean, yeah, as Carolyn said, plastic burns. So if your insulation's not plastic, it'll probably be better.
Yeah. Well, and again, it's understanding the whole system too, right? Like it needs to be built in with other materials that create that fire rated sort of assembly. You can't swap out one thing for another and expect it to work the same way. So you have to know, what you're doing and why you're doing it so that you can do it in the way that's going to perform.
Someone's asking about a product called Enviro Shakes that are recycled car tires. Does anyone
I
have?
use them. Yeah, they're great. They look great. I'm not sure what the asking is. I don't know offhand what the what the embodied carbon is, but I'm
Mhm.
sure it can be looked up. It's not, was it in the beam calculator? I'm not sure. I don't think so, but yeah, I'm curious now. It's been a while since I used it. I'm gonna go look it up,
Okay.
see where it's at.
Okay, so now Nick's got a couple of questions. What is the approximate budget that you would set for prepping these calculations? If you can answer that, again, I'm sure there's a huge range depending on the complexity, but you're comfortable giving ranges. And question 2, how do you verify the design energy savings against the as-built? Any takers on that?
Like you said, Claire, it's really hard to estimate what the budget would be to because it depends on what kind, like if you're doing a simple 2-story house compared to a 5,000 square foot house with lots of turrets on it, it depends on how complex the shape is. But again, it goes back to what the goal is in the end. If you're trying to do better, then you don't need a fully accurate model. You just need to get a model that's close enough to the area. Beam works off of square footages. So you need a square footage of exterior wall, you need a square footage of roof, you need square footage of foundations. And so as long as you get that close enough, the beam calculator is not that difficult to use. And it's just like, we do with our templates for our drawing systems, where the setting up of the first template takes a long time, but then after that, it's much easier. You can use it and replicate it, and it's much easier. So it's I would say, think of it in that way. Like the first time you ever set up your drawing standards, it's going to take like that long. And then after that, it's much easier.
Yeah. Like it sounds like a bit of an investment in terms of
Yeah, I will say the beam calculator in particular is pretty intuitive, but it does still take some time to make sure you're getting it right, and you want to make sure that you're being thorough, right? Because if you miss pieces, then you could think you're getting results that are way off. So yeah.
Yeah, any other thoughts just in terms of someone's asking about charging a per diem, and something I see from the regulatory side is often I don't think architects charge enough for their services, and often we'll get into that's sometimes on the complaint side where we see things go wrong. So I'm just wondering if any of you have any like a general kind of advice when you're working with clients to really kind of advocate for the reasons for the costs, and if you found like clients being more receptive when you take certain approaches, or if there's been anything there that you can offer to, because unfortunately these aren't requirements. So sometimes people might think of it as like a luxury or something. So are there any things that you've learned along the way that would help you address like getting paid fairly for the work that you're doing, and also the kind of work, like the value, the larger kind of picture of it? I know it's a bit of a broad question, but if you had any thoughts for the audience today.
I have lots and lots of thoughts on that. It's very, very difficult. And that's exactly why we've taken the approach that we have, where we don't do a detailed model for every project. We just couldn't justify it. But at the same time, we want to generate case study. What I think is that if we can share the information, and to share the information, we need to do some modeling of those projects, but then that's going to get the information out to the people who hopefully will be our ideal clients and who are going to want that information for themselves. Because if you have a client that's coming to you and saying, I want to do a better job environmentally, then you want to be able to show them that you have done a better job and to quantify that. And so, of course, that's going to take a bit of extra fees, but then you've got your ideal client with you. So That's the way I look at it.
Mhm.
Yeah, I think it's positioning yourself as an architect, as a firm, as someone who does this work as a baseline. You know, it's included in every project, or like the fundamentals are included in every project, and that's just an understanding. And I think what I'm finding is that more and more clients, more and more people are sort of starting to shift in the direction of seeing this as something that's really important. And so it's not a bonus, it's not an extra feature, it's something that is starting to become an included, like a needed feature. I'd love to see that more, but
And I think it's also framing it in a different way to say, okay, maybe this isn't a requirement, maybe it isn't a standard that we have to meet, but as a result of this work, you're going to have a house that's healthier. It's going to be more economic to run over the lifetime. It's going to be more resilient if there's, you know, wildfires around. Like, it's going to be more comfortable. Like, there's a lot of bonus things building in this kind of way that people are really really interested in. So
and
just
people
because
know
there's
what
not
they're
a
getting.
standard.
They know what they're getting when they come to you, right? Because like it's front and center. It's not a bonus. It's not an added value feature. It's just something that's inherent in what we do. They come to us because we do it, is what I find.
Okay, well, that's good to hear. I love to hear that. We are a couple of minutes. We actually have one more poll before I have and Shalika's just going to launch it now. Before we close out, just to ask whether you feel better equipped to track your CUI now.
Carbon use intensity.
Thank you. It's good to say the acronyms out loud. There's a lot of yeses coming in. This is great to see. I get to see, as the host, I get to see the numbers in real time, and just about everybody who's answering is saying yes. Okay, I shouldn't skew that, sorry. They're still answering. Yeah, it's a good chunk of them now.
Right. If you're not sure, go download the beam calculator and
yeah, if you're
play
not,
around with it.
only 2 people that weren't sure, so maybe we can share that result now if we're not. Oh yeah, we're sharing. So yeah, wonderful. 95% of people feel that they're better equipped. Okay, great.
Hopefully the other 2 already were well equipped.
Yeah.
There you go. It could just be that they were here because they knew everything already, right?
Right.
Okay, so we just have a couple of closing announcements. I don't know if there were any, anybody had any parting thoughts before I have some housekeeping? Carolyn,
I would just say get started.
yeah, and keep here. You're attending today's webinar, so and you've got these 4 classes. So Carolyn, Brad, Kim, Chloe, thank you so much again, and we'll keep inviting you back because I know this area is constantly changing, so it's going to be a continuing conversation as the landscape changes. So just a couple of, again, as I noted, next week we have another Thursday webinar on well-being by design, a purpose-driven built environment. Should be really interesting and engaging. We've also got a special risk management webinar that's being offered at the end of the month on professional responsibility under municipal renovation bylaws. So that's, again, a pretty niche area if you're in Toronto, if you're doing any residential, like people on the call today. Some really valuable, important information to keep on hand. So that one's on Thursday, October 30th. For those of you who attended 80%, we will be reporting it, as I mentioned. And as I mentioned before, just give us a little bit of time, and we ask for your patience as we process your hours. We will also be sending you the file. I think maybe Kim or Chloe mentioned that at the beginning. So you'll have these beautiful slides and all these wonderful links. And so continue to do your research and work on these areas. And of course, we'll be sending you a survey. So if you have any feedback for the speakers and any comments that you want to make, we really do value that. I say that sincerely. It's such an important conversation to have. So I encourage everybody to just take a couple of minutes and share their thoughts with us. And thanks again for those on the call. Thank you again to our wonderful speakers today. Have a wonderful remainder of your day, everybody. Take care. Bye.
Thank you.